Hi friends, in the previous videos we have discussed about types of signals and their classification and some problems on periodic and non-periodic signals. In this video I am here to explain you about elementary signals. There are many types of elementary signals, but in this video let us discuss about three types of elementary signals. They are, first one is unit step function. Second one is unit ramp function. Third one is unit parabolic function. So in today's video I will tell you about unit step function, unit ramp function and unit parabolic function. First topic is unit step function. It is an elementary signal. So unit step function can be defined as, in a mathematical equation, it is denoted with u of t. The value of u of t is 1 for t greater than or equal to 0 and 0 for t less than 0. Once again I will tell you, unit step function is denoted by u of t. The value of u of t is 1 for t greater than or equal to 0 and 0 for t less than 0. If we draw the signal will be like this. Consider this as x-axis and t is taken on x-axis. It is u of t 0. Here at 0 the value is 1 and greater than 0 the value is also 1. So the graph goes like, the signal moves like this. At the value of u of t is 1 for t greater than or equal to 0 and it is 0 for t less than 0. This is a continuous time unit step function. Next, there may be a delay or advanced unit step function. It means there is shifting in this unit step function. We will observe that signal also. Next one is shifted unit step function. Generally, unit step function is denoted by u of t, but shifted unit step function is denoted by u of t minus a, because actually the signal starts from 0. In shifted unit step function, the signal starts from point other than 0. It is delayed or it may be in advanced situation. If we consider u of t minus a, the value in the brackets, that is equate t minus a to 0, then t is equals to a, which means the signal starts from a. In the same way as we written before, let us write the mathematical equation here. U of t minus a is equals to 1 for t greater than or equal to a and 0 for t less than a. If we draw the signal, it will be like this. It is 0, it is 1. Let a point A be here, t, u of t minus. The signal is starting at A. At A, its value is 1 and it goes on 1 until infinity. Before A less than A, its value is 0. So there is no signal here. The signal starts at A. To know it simply, just equate the value from u of t minus a to 0. T minus a is equals to 0, t is equals to a. It means the signal starts from a. If it is given u of t plus a, then t plus a is equals to 0 and t is equals to minus a. For example, the shifted signal is u of t plus a. T plus a is equals to 0. T is equals to minus a. It means the signal starts from minus a. This is about shifted unit step function. Next, let us say ramp function. Before going to see about unit ramp function, let us discuss about discrete time unit step function. Just till now we have discussed about continuous time unit step function. Now let us discuss about discrete time unit step function. For continuous time unit step function, u of t is equals to 1. Whereas in discrete time, we have to take it as u of n. U of n is equals to 1 for n greater than or equal to 0, 0 for n less than 0. It is same as continuous time unit step function, but in place of t, we have to write n. Just we need to replace t with n. That is the change that we have to do here. And again, there is a slight change in the signal diagram. I will show you it. Consider this as x-axis. Let us take some coordinates -3, -2, -1. Here the signal starts from 0. So it will be like this. At all the points, its amplitude is 1 and it goes on. This is the discrete time unit step function. Let us see the shifted version of discrete time unit step function. The next one is shifted version of unit step function. Now let us take u of n minus a, or else let us take an example u of n minus 2. The value of it is 1 for n greater than or equal to 2, 0 for n less than 2. If we draw the signal for this, the signal starts at 2. So the discrete time signal starts at 2. So here the value of it is 1. Here also it is 1. It goes on until infinity. The value of the signal is starting at 2 and its amplitude is 1. This is about the shifted version of discrete time signal of unit step function. Next one is unit ramp function. One is unit ramp function. The unit ramp function for a continuous time signal is denoted by r of t. The value of r of t is t for t greater than or equal to 0, 0 for t less than 0. The unit ramp function of a continuous time signal is denoted by r of t. Since it is ramp function, r of t is equals to t for t greater than or equal to 0 and 0 for t less than 0. Generally, we know that u of t is equals to 1. Therefore, we can write r of t is equals to t into u of t. This is the relation between r of t and u of t. R of t is equals to t into u of t, since u of t is nothing but 1 for t greater than or equal to 0. If we draw the signal for r of t, then it will be like this. I will show you. The slope of the signal is 1. This is about unit ramp function. Let us see the shifted version of unit ramp function, delayed unit ramp function. If the signal is delayed, then the signal becomes r of t minus a, which is equals to t minus a for t greater than or equal to a and 0 for t less than a. It means the signal starts from a. Then the signal is like this. This is the signal r of t and this is the signal r of t minus a. The signal starts from A. Since it is a delayed ramp signal, it starts at A. We know that R of t is equals to t into u of t. This is the relation between unit step function and unit ramp function. We can also say that R of t is equals to integral u of t. The integration of unit step function is nothing but ramp function. The integration of unit step function is nothing but ramp function. R of t is equals to integral u of t dt. What is u of t? 1. So integral 1 dt is nothing but t for t greater than or equal to 0. So we can say that R of t is equals to integral u of t dt, or R of t is equals to t into u of t, or we can also write it as u of t is equals to d by dt of R of t. These are the two main relations. R of t can be defined as integral of u of t dt, or u of t can be defined as derivative of R of t. Next, let us see unit ramp function for a discrete time signal. Till now we have discussed about continuous time signal unit ramp function. Now let us see unit ramp function for a discrete time signal. Unit ramp function for a discrete time signal. As we know that in discrete time signal, the t should be replaced with n. So we should write R of t as R of n, which is equals to n for n greater than or equal to 0, and 0 for n less than 0. This is about unit ramp function. In the same way, we can derive the relation for unit ramp function and unit step function. R of n is equals to n into u of n. Let us see the signal diagram for this. The signal starts from 0. At 1, its value is 1. At 2, its value is 2. At 3, its value is 3. At 4, its value is 4. Since the slope of the signal, the slope of unit ramp function is 1, so at 0 its value is 0, and at 1 its value is 1. 3 its value is 3, and at 4 its value is 4. This is about the unit ramp function for a discrete time signal. Now let us see shifted version of discrete time unit ramp function. Shifted version of discrete time unit ramp function. Let us consider a signal R of n minus 2. This is the example of shifted version of discrete time unit ramp function R of n minus 2. R of n minus 2 is equals to n minus 2 for n greater than or equals to 2, and 0 for n less than 2. So we can write the relation for shifted unit ramp function and shifted unit step function as R of n minus 2 is equals to n minus 2 into u of n minus 2. Generally, the ramp function starts from 0. At 0 its value is 1, and at 1 its value is 1. At 2 its value is 2. But shifted version of this function starts in this R of n minus 2. The signal should start from 2. So at 2 its value is 0. At 3 its value is 1. At 4 its value is 2. At 4 its value is 3. Sorry. So let us see the diagram, then you may get a clear idea about it. Here the signal is starting from 2. So at 2 it is 0. At 3 it is 1. At 4 it is 2. at 5 it is 3. This is the shifted version of discrete time unit ramp function. Once again I will tell you about unit ramp function for a discrete time signal. For a discrete time signal, the unit ramp function R of n is equals to n for n greater than or equal to 0. It means the value of n starts from 0 and it is 0 for n less than 0. The relation between unit ramp function and unit step function is R of n is equals to n into u of n. In the same way, let us see the shifted version of discrete time unit ramp function. Here I have taken the example of a shifted version to make you understand clearly. So let us see R of n minus 2. It is the shifted version of discrete time unit ramp function. So R of n minus 2 is equals to n minus 2 for n greater than or equals to 2 and 0 for n less than 2. So since the signal is given R of n minus 2, the signal starts from 2. At 2 its value is 0, at 3 its value is 1, at 4 its value is 2, and it goes on increasing by a single digit number. So this is about the ramp function or ramp signal. Next one is unit parabolic function. Third one is unit parabolic function. Unit parabolic function is denoted by P of t. P of t is equals to t square by 2 for t greater than or equal to 0, 0 for t less than 0. The unit parabolic function is denoted by P of t. P of t is equals to t square by 2 for t greater than or equal to 0 or 0 for t less than 0. The relation between unit parabolic and unit step function is P of t is equals to t square by 2 into u of t. Let us see the signal diagram of P of t. Since it is a parabolic function, the signal appears like a parabola. Starts from 0, it goes on like this. This is a signal of unit parabolic function. Let us see the shifted version of unit parabolic function. Shifted version, it means the signal is shifted towards right or left. Let us see the delayed version of parabolic function. It is P of t minus a, which is equals to t minus a whole square by 2 for t greater than or equal to a and 0 for t less than a. This is the shifted version of parabolic function. Here the signal starts from a. The same signal is starting from a. This is about, here the signal is shifted and starts from a. This is about the unit parabolic function, and the relation between unit parabolic function is P of t is equals to double integral of u of t. The parabolic function is obtained by double integrating the unit step function. We know that integral u of t is nothing but integral r of t dt. R of t is integral t dt. Integral t is t square by 2 for t greater than or equal to 0. This is the relation between P of t and u of t, or we can also write it as u of t is equals to d square by dt square of P of t. This is the relation between P of t and u of t, that is, it is the relation between unit parabolic function and unit step function. In the same way, let us write the relation between unit parabolic and unit ramp. P of t is equals to integral r of t dt. Integral t dt t square by 2. So r of t is equals to d by dt of P of t. These are the most important relations between u of t, P of t and r of t. This is about the unit parabolic function. In the same way, let us see the discrete time unit parabolic function. The discrete time unit parabolic function is denoted by P of n. Therefore, it is written as P of n is equals to n square by 2 for n greater than or equal to 0 and 0 for n less than 0. The shifted version of discrete time parabolic function is P of n minus a is equals to n minus a whole square by 2 for n greater than or equal to a and 0 for n less than a. These are the discrete time shift. This is the discrete time shifted version of unit parabolic function, and this is the discrete time unit parabolic function. This is about the three types of elementary signals. The first one is unit step function, second one is unit ramp function, third one is unit parabolic function. In the unit step function, u of t is equals to 1 for t greater than or equal to 0 and u of t is equals to 0 for t less than 0. Whereas in ramp function, r of t is equals to t for t greater than or equal to 0 and r of t is equals to 0 for t less than 0. Whereas in unit parabolic function, p of t is equals to t square by 2 for t greater than or equal to 0 and 0 for t less than 0. The relation between p of t and u of t is p of t is defined as the double integral of u of t or single integral of r of t, and u of t is equals to d square by dt square of p of t, or r of t is equals to d by dt of p of t. These are the first three types of elementary signals. We have many other types of elementary signals. In the next video, let us see some other types of elementary signals. Thanks for watching the video.